Well, good afternoon, everybody. It's a great pleasure to welcome you here to the Clarendon Laboratory, and not only to welcome people who are here, but I know there are a number of people watching online or will be watching the recording, so a warm welcome to you too. We're celebrating the 150th birthday of the Clarendon Laboratory this year, and hence this celebration. Of course, physics in Oxford has been going for much longer than 150 years, beginning in the 12th century. And we'll hear a little bit more about that, so it's a much longer tradition. And the Department of Physics is much younger than the 150 years. So this idea of coming together as a group of physicists in different disciplines and forming a single department is a relatively recent invention. So Oxford takes always a few centuries to get used to these strange ideas. So, but we are celebrating the 150th anniversary of this laboratory, and you can see in the picture behind me the Clarendon Laboratory at various stages. It's now grown additional buildings, and it's not on its original site. We're going to hear about that in a moment. So what's going to happen today is we'll hear a couple of talks. Each will be about 15 minutes, and then after that we will wrap up and go for refreshments in the common room. So I'll give you details on the arrangements for that when we've heard the first two talks. But first I'd like to invite Timothy Baker to give the first talk. Timothy is the son of Michael Baker. Many of us remember Michael as a much valued and dear colleague who was here for many years. And Timothy has been thinking a lot about the history of the laboratory, so he's going to speak to us first of all.
It's a great honour on this auspicious occasion to be allowed to speak where my father used to lecture so often. So the 150th anniversary of the Clarendon Laboratory. On the right, we can see the illuminated manuscript, the illuminated parchment that's just outside the door here, commemorating its foundation. Do I have a pointer at all, or I think that points, does it? Yes. Up at the bottom, that's the top right corner, is the operative date 1872, a bit small. At the top we have a miniature portrait of Edward Hyde, First Earl of Clarendon, who was Chancellor of the University in the 1660s, also grandfather of Queen Mary II and Queen Anne. It was another of his grandchildren, Henry Lord Hyde, in blue just here, who actually bequeathed the money to the university, although it was derived from the profits of selling his grandfather's papers. So here is a bigger portrait of the first Earl of Clarendon, and his earldom was named after Clarendon House, which was the Hyde family mansion down near Salisbury. Other names, just a note on the parchment, we can see in red and black the 5 Clarendon trustees. First one is the then Duke of Marlborough, who 2 years after 1872 had a grandson born at Blenheim Palace called Winston Churchill. And fourth is William Ewart Gladstone, who took time off from his part-time job as Prime Minister to do the negotiations with the university. And then finally, at the very bottom, rather inconspicuous here in gold, is Robert Bellamy Clifton, Professor of Experimental Philosophy, who is the true founder of the Clarendon Laboratory. Just remind ourselves quickly of the prehistory of Oxford physics. These two pictures encompass it quite nicely. This is the view from the King's Arms corner, the bottom of Parks Road. We can see just a pinnacle of Merton Tower here, where the Merton calculators initiated quantitative mechanics in the 14th century. Then at the bottom of Cat Street, just to the left along the High Street, was Deep Hall, where Robert Hooke and Robert Boyle researched the vacuum and air pressure. They, along with others in the Oxford Philosophical Society in the 1650s, wanted to establish a school of experimental physics here in the gallery of the old school's quadrangle. Must stop pressing this. but that was abortive. The school's tower, of course, was the observatory of the civilian professor of astronomy. Just off-screen to the left was Hart Hall, now part of Hertford College, where John Keel and John Desaguliers were among the first to lecture on Newtonian mechanics anywhere in the world. Here on the right is the old Ashmolean Museum, where university lectures in experimental philosophy began in 1715. They moved in 1832 to the first floor of the Clarendon building here, which came to be known as the Clarendon Science Museum. As a result, it was shared with geology and mineralogy. So you get a number of extra anniversaries today, and the first of these is the 190th. It's 190 years since the name Clarendon was first associated with Oxford physics. In 1860, Robert Walker was appointed first Professor of Experimental Philosophy, and he moved into the new University Museum on the right. His rooms are actually obscured in this picture by the chemistry laboratory, the Abbott's kitchen on the ground floor, but the only surviving remnant now is the label above his door in the quadrangle of the museum. And here on the left, we can see the old Clarendon Laboratory, and note how small a scale it has relative to the museum. Kurt Mundelssohn later described it, fresh from his institute in Germany, as a small chalet of Venetian Gothic. So what Lord Henry Hyde actually left the money for was to establish a Clarendon riding school. The funds accumulated for a century, and when they were offered to the university said, no, we don't want a riding school. Could we use the money to fund the Clarendon Parks, please? The maintenance of Clarendon Parks. The trustees said, no, we're looking for something more substantial than that. And at this point, the new professor of experimental philosophy, Robert Clifton, asked the university for funds to extend his rooms in the museum. This was just the point at which laboratory teaching of science was coming in. The university said, okay, but what we'd really prefer is a new Clarendon examination schools. The trustees said, no, we like the physics laboratory, very wisely. Just to note, it was originally going to be called the Hyde Institute. There was a late bid for a Clarendon swimming bath, but the Dons were worried that the undergraduates would all drown, which conjures up a rather splendid Zuleika Dobson image. So the laboratory was built. It was the first of the laboratories to break out of the museum quadrangle. It was the first purpose-built university physics laboratory in England, preceded in Britain only by William Thomson, Lord Kelvin's at Glasgow. And just to note here that this is actually a rather extended anniversary, which started in 1870 when Clifton first started to use the old Clarendon Laboratory. By late 1871, they'd moved completely and chemistry took over the old rooms in the museum. But 1872, as we've seen, is the date of formal completion. And just to note that James Clerk Maxwell copied the Clarendon for the Cavendish. Unfortunately, the Cavendish stayed ahead of the Clarendon for a long time after that, but we'll come to that in a minute. Here is, I think it's Thomas Keeley's photograph of the old Clarendon in all its glory in about 1939. And we can see here the turret which marked the professor's rooms. And on the right is Professor Clifton himself. He was a huge man, apparently, well over 6 feet, and he was said to resemble a Chinese mandarin. I think it was not just the moustache and beard, but he had very long fingernails as well. in spite of which he was actually a very good experimentalist and demonstrator. And the lab prospered for the first decade of his tenure. Things went a bit awry after his great supporter, Henry Smith, the pure mathematician who was also keeper of the museum, died in 1883. And as research became more and more important, Clifton notoriously didn't do any and didn't encourage his staff to do so. He bid for funds for a new electrical laboratory in 1887. That was rejected. So he was understandably upset when the university did establish an electrical laboratory in 1900. It was set up completely independently under John Townsend, who, like Clifton, was an import from the other place. But Townsend was brought in specifically to introduce the Cavendish style of research that had been introduced by his supervisor, colleague, J.J. Thomson. Clifton must have been even more upset when the Drapers Company funded this palatial laboratory for Townsend. Now, of course, the Townsend building and the two laboratories operated side by side in rivalry and with a lot of tension for 40 years. So Frederick Lindemann replaced Clifton after the First World War. Just another anniversary to note here, the statute for the Dr. Lee's professorship is dated 1915, but it was endorsed by the Asquith Committee in 1922. So it's 100 years of the Dr. Lee's professorship. I gather that Professor Radaeli sent his apologies today, but you'll be able to inform him that he's got his 100th birthday. Frederick Lindemann rapidly introduced a program of research. One of his first DPhil students and one of his demonstrators 100 years ago was my grandfather, Dudley Perfect. But research really took off, as did the Clarendon, in the 1930s, when Lindemann gave refuge to the German refugees. As a result, the old Clarendon was really bursting at the seams. So this new Clarendon laboratory was built in 1939-1940. It was the first laboratory in the newly designated science area. The university provided funds for that. Unfortunately, they didn't provide any funds for apparatus or staff. But fortunately, the Second World War came along, and there was a moment when this building was about to be turned into a military hospital because it was all freshly built and empty. But Lindemann managed to persuade the government to turn it into a military research laboratory, particularly dealing with radar and later with isotope separation for nuclear weapons. This is a picture of the new Clarendon in its original form. We can see on the left the high tension room then without any windows, and on the right the dear old chestnut tree, horse chestnut tree out in the front courtyard on the site of the Croft building. The whole laboratory, Lindemann actually persuaded the university to move 6 feet back into the university parks in order to provide space for the horse chestnut. So having spent 75 years crammed into a single building, in its second 75 years, the Clarendon Laboratory grew and morphed and expanded in all sorts of ways. It took over the electrical laboratory in either 1941 or 1945, depending on which source you consult. It put up new buildings, and we should note here that it was A.J. Croft who suggested the Lindemann, Townsend, Simon nomenclature for the lab's buildings. A series of new sub-departments grew out of the Clarendon, particularly in Bleeny's time as successor to Lindemann as Dr. Lee's professor. And the Clarendon was also partly the origin of the astrophysics department, along with the University Observatory. Then in the 90s, we had the grand reunification, as Stephen was saying, with everything coming back together under the chairman of physics. And that was not just a grand reunification, it was a merger of everything, in the sense that physics came together with astrophysics, from which physics had originally split. Well, not really in 1839, as I've written there, but really from the 18th century, the physics emerged from under the wing of the professor of astronomy. So, finally, what's left of the old Clarendon Laboratory? Well, surprisingly much. We should just note that this year the thin film facility has been established in part of the site of the old basement of the Clarendon Laboratory, the old Clarendon Laboratory. So physics is back on its old site. These two pictures to the right show that when the old Clarendon was rebuilt as the geology laboratory after the Second World War, it was very much using as much as they could of the original structure. Those were the days of austerity and scarce building materials, and the old lecture theatre was retained until 1963. Now the only bit you can see from the outside is a few of these windows on the other side of Sherrington Road, but there is much more inside, as I discovered last week when Stephen Hill, the computer science buildings manager, showed me round. We have here the central hall and a corner of it. It was originally double height with a gallery, which has now been floored over, but these are the original walls and the original supports for the gallery. And there's also a rather splendid Gothic staircase in the University Museum style as well. Out at the back here, amongst the workshops, is the old namestone from the 1872 laboratory. This picture shows it in its original position and shows that there wasn't room for all of the inscription when it was relocated. So the word laboratory here, it's not very easy to see, has been omitted from the reconstruction. So that's the Parks Road's entrance of the old Clarendon. Much of the old basement is still there, and in one of the vaults was where Charles Boys measured the gravitational constant and the weight of the Earth, and I think that Valeria has brought out some photographs of Boy's apparatus. Also, it was where the International Seismological Survey kept its seismometer. So well over 100 years before the Croft building, the Clarendon Laboratory was the most stable place to do experiments in Oxford. Now this is the final supplementary anniversary of the day. 90 years ago next month, on 13th of January 1933, Kurt Mendelssohn made the first liquid helium in Britain, which was something of a pivoting point in the history of Oxford physics, because, well, partly it was the swan song of the great German school of physics, because 3 months after this event, of course, Hitler decimated German physics with his expulsion, his exclusion of Jews. It's also the origin of low temperature physics at the Clarendon and of the golden age of research that followed. And we have here, courtesy of Mr. Hill of the Computer Science Laboratory, who now occupy the old Clarendon, the very plaque itself that Lindemann put up to commemorate this event when the laboratory is refurbished in the 1940s. I think the most important aspect of this from Lindeman's point of view was that the Clarendon Laboratory had finally beaten the Cavendish at something which we've done often since. But this plaque was actually rescued from the brink of the skip by Mr. Hill during refurbishment work. So a vote of thanks to him. And there are plans to reinstate it on or close to its original site, which he's coordinating with Mr. Probert of the Clarendon. There's a story about Nicholas Curtie, who allegedly, and the geologists had a big gentleman's lavatory for all of the people coming in from the field to clean the mud off themselves. And Curtie wanted to put above the urinals in this lavatory a plaque saying Kurt Mendelssohn first part, Felix Mendelssohn first passed liquid helium here. Sadly, it wasn't to be, but what Nicholas Curtie did publish was an obituary for A.J. Croft, whose 1986 typescript history of the Clarendon Laboratory, Mike Wells and I have been working on transcribing over the past couple of years, and I believe today it's due to be, and indeed Valeria signals to me it has been published on the Oxford Physics website, and Mike Wells is a much better qualified person to speak about A.J. Croft than I am. So over to you, Mike.
Well, thank you, Timothy, for filling in the last 400 or 500 years. My job is just to fill in the last 60 years, which is the time that I've been coming through the front door of this building, coincidentally. A.J. Croft, known to one and all as A.J., and it was strange to me that when I found this manuscript at the start of COVID breakdown and there was little else to do at home, and I went through my various bits and bobs, I found this manuscript with no front page, and I was puzzled over exactly who did write it. But Timothy, very quickly, when I passed it to him, established that it was A.J. Croft. And although he was known to everyone as A.J., strangely, his title page, when we finally found it, was by Anthony Croft. And that was the first time in 60 years I've ever known him acknowledge his real Christian name. You might say, why is it me standing here today when I'm in the presence of Bill Hayes, who's been here, I think it's 10 years longer than me, Bill. But so congratulations, nice to see you here today, and I'm sure we all welcome you back. But it's some 1962 when I first met A.J., when I came here to work with Dr. Cook, Arthur Cook. And so I knew A.J. right back from that time in 1962. A.J. was a graduate of Christ Church College, and his tutor was the late C.H. Colley. He was a bit of an experimentalist from the early stages, was A.J., and he managed to get various jobs in the teaching course during the vacation, which led him in turn to the attention of one Nicholas Curtie, who in turn recommended him to Sir Francis Simon. And in 1947, Simon gave him a temporary job from which he was duly noted by Mr. Keeley, a one-time director of the Clarendon Laboratory. In turn, Keeley gave A.J. a position, which later apparently was to the disapproval of Lord Cherwell, or so the story goes. But nevertheless, A.J. survived, and in the fullness of time became the administrator of the Clarendon Laboratory. This was at a time when most of physics, as Timothy has alluded to, was concentrated in the Clarendon Laboratory. In the two buildings housed all aspects of physics. And later, in the 1960s, that was, because of their increasing size, was put out to other buildings and departments around Oxford. Strange to think that this was the 60s when things were pulled apart, and later on in the 80s, Chris Llewellyn-Smith spent his time putting them all back together again as a unified physics department. A.J. was charged with putting cryogenic facilities in Oxford on the map. And his skills in engineering and cryogenics were supreme. He developed and engineered early transfer lines, which a lot of people misnotedly call them siphons, and complex heat exchangers for use in the liquefiers. But he admitted that whilst he understood most matters pertaining to thermodynamics, in matters of entropy, he always referred to Nicholas Curti. And come to think of it, so did most of us at the time, because Nicholas was the man who really understood entropy. At the end of World War II, liquid helium was localized in individual dewars, so the experiments had to be put in the same dewar into which helium was liquefied. And A.J. was essentially charged with making free helium, as it were, to everyone. Moreover, at that time, we had no liquid nitrogen supply. In fact, we had only oxygen, courtesy of Presteel Fisher establishment out on the Ring Road. And A.J. was responsible for the new hydrogen liquefier in 1961. He engineered and changed all the schemes relating to cryogenics quite dramatically. He engineered and produced a new helium liquefier using the Joule-Thomson expansion technique and a pumped liquid hydrogen pre-cooling stage. And that hydrogen was supplied in the end by an overhead transfer line from the hydrogen liquefier across the yard into the helium liquefier. And he also installed, of course, a much larger and commercial supply of liquid nitrogen, which is the base cooling material that everyone wants. So in fairness, we should say that the rise in cryogenics and low temperature physics in the Clarendon Laboratory through the 1960s and 70s and into the 80s was very much the legacy of A.J. Croft. Now, a little more about the man who has produced this manuscript. He was born in 1925 and died in 1988, aged only 63. A.J. was a bit of an enigma to everyone who knew him. He was a product of Westminster School and Christ Church College, and he retained many views of an earlier lifestyle. He was a great swapper of stories, in fact, a gossip monger amongst us all, because he would always call us in and ask what was the latest bit of information going around the lab. He had a great fondness for music and was a member of the Bath choir. He enjoyed a dress style that was very much 10 or 20, 30 years earlier, always including a suit and a waistcoat, which is not something you see in the laboratory these days. It was very much a behavior that was post-war era. He had strict views on etiquette and social behavior. And I can recall the time when Nicholas Curti told us the story of how a group of people collectively with A.J. would hold forth about which of the current intake of female undergraduates could be strictly termed as ladies. He would not have lasted very long in today's age of equality. but that was A.J. It was the way he was. As an administrator of the department, he was very clear about all matters, including who should park where. And it reminded me, when I got to this point, about the story of the visiting dignitary from Presteel Fisher. This was sometime in the 1960s. And it was discovered one day that a car was parked outside the Lindemann building, who A.J. had no recollection of who owned it, or any registration had been recorded. And so, because it was parked inconveniently, as he put it, he went outside, lifted the bonnet, and removed the rotor arm from the distributor head. Needless to say, this dignitary, having been meeting with Brevis Bleeney, came out and couldn't start his car. And there was a slight hiatus which followed this episode, but the outcome, thankfully, was good, that Presteel fellowships were available for graduate students for some time in the 60s and early 70s. A.J. was strangely English. He never went abroad. He only went to Scotland once, and he returned and complained that the policemen there wore silly hats, and therefore it was a country not to be worth considering. Sadly, his diabetes was congenital and in time led to blindness, which was very sad because at that same moment, he was just elected to the MCC. And I was the beneficiary of his election because for many years I had tickets for the Lord's Test match, courtesy of A.J. He was a keen cricket follower, and he fostered the Clarendon Cricket Club and promoted the annual Cavendish-Clarendon cricket match. And as far as I know, and I stand corrected on this, it is recorded somewhere that the highest partnership in said match was by ones Brevis Bleeney and Cyril Band. Sadly, the combination of his somewhat archaic and aged views amounted almost to a snobbish attitude. And that didn't collectively endear him to the staff, mainly the technical staff, who essentially he was their line manager. When Bill Mitchell replaced Brevis Bleeney as Dr. Lee's professor, some animosity arose about A.J.'s capabilities, and in truth, these were very much amplified by A.J.'s blindness as a result of his diabetes. A.J. was initially absolutely disbelieving that the selectors should choose a new Dr. Lee's professor from Reading University. I was astounded by it. But it was typical of A.J. that he was unable to see the bigger picture. He didn't realize that what the Clarendon was crying out for then was someone with an expertise in neutron diffraction. Bill Mitchell, therefore, tried to persuade A.J. to take early retirement, which A.J. viewed as being sacked, and he objected very strongly to this and fought it tooth and nail. The compromise situation was that A.J. was told to concentrate on his book of history and leave the running of the department to others. A.J.'s death in 1988 left the manuscript in limbo. And although we found several copies around, one in the archives and one in, was it the museum? In the Radcliffe Science Library. It was strange, though A.J. tried to get it published, it never actually occurred. The manuscript was turned into a typescript with the help of several secretaries in the Clarendon. Some lasted longer than others under A.J.'s rather critical eye. And coupled with the effects of one Kieran Angwin, believed to be a gap year student, we should say that the final product was very much a result of his wife, Margaret Croft's efforts. and as a long-suffering amanuensis to all his whims. Without her efforts, I don't think the manuscript would ever really have been left around after A.J. died. It's already a rather an odd coincidence, as I said earlier, that I found this at the start of COVID without its cover page, and I handed it to Timothy Baker, who very quickly established that it was. I know for a fact that although this is only a publication online, A.J. would have been very proud of the fact that his efforts had borne fruit 34 years after his death. Finally, it has to be said, for those of us who've read it, the manuscript is quite interesting, especially those who want to see the physics of Oxford in a historical complex. And it is worth the reading, but every credit should go to A.J. Croft for his diligence in producing it in the first place. Thank you.
Yes, so thank you very much, Mike, and thank you to Timothy for that perspective on the history of Oxford physics. Of course, we've seen a lot about buildings and the different buildings that have made up the Clarendon Laboratory over the ages, but this is also a reminder that it's also a history of people, sometimes flawed people, but people who care about physics and care about this community. And so I think what's wonderful about this occasion is we've not only been looking back, but we've also got various people here. All the people in the audience are either part of the Clarendon present or the Clarendon past, and everyone has contributed to this community of physicists and made this place what it is now, a very vibrant place where all kinds of exciting things are happening in the present. One of the hottest areas in physics is quantum computing, and that's a topic that began here in the Clarendon Laboratory, and there are lots of examples like that. So this vibrant place continues to do wonderful things.